Assalamualaikum and hello everyone. In this lecture, I will talk about one of the subtopic of crude oil distillation, which is preheating. For that, how are you all doing? I hope you are doing well in this situation. I hope that this phase will be end soon, inshallah. So happy fasting everyone. So let's move on to my topic. My topic is preheating. It is sub topic in crude oil distillation. Before that, let me introduce myself. I'm Nur Aina Shafira bin Harun. My mentor number is 192499. Okay, now before I explain to you what is actually preheating process, let me explain a little bit more about crude oil distillation. I think all of you might familiar this topic before. We already learned crude oil distillation in refinery course. So let me refresh back. Okay, what is crude oil distillation? Okay, any idea? Any idea? Okay, so crude oil is made up from mixture of hydrocarbon, and crude oil it is a raw material for any process. The function of the distillation is to separate the crude oil into the different fraction. Okay, crude oil will be first heated, and then they will be put into the distillation column, where they are different product will be boiled off and they are recovered at a different temperature. And crude oil distillation is actually the highly complex process, very most critical process that in reducing energy consumption in heat integrity. Okay, next one. Okay, preheating. Let's move on and focus more on preheating. I will focus more on crude preheat train. Crude preheat train is subunit in crude distillation unit. It is located at the beginning of the crude distillation unit. Crude preheat train is designed to achieve efficient energy recovery. Okay, design of crude distillation unit will be with same column and several strippers and pump around. Okay, let me see the design of crude distillation unit. Okay, this is the design of crude distillation unit. Okay, crude preheat train. I said before that it is located at the beginning of the crude distillation unit. Okay. In crude preheat train, it consists of two stages, which are cold preheat and hot preheat. Okay, they will be separated by desalter. The function of desalter will be separate the salt and sediments. Later will be discussed by Nitya. And then after crude preheat train, it will be entered into the furnace, and then they will be separate or they will be entered into the distillation column, which consists of reducing crude, heavy gas oil, light gas oil, kerosene, and naphtha and gases. Okay, I will explain the process of preheating. Okay, I said before it consists of two stages, right? Cold preheat and hot preheat. After that, the temperature required about 270 when crude oil enters into the furnace, and the furnace will be heat the oil to temperature that required to the distillation column. Okay. Crude oil will be heated about 360 to 370 before it enter into the distillation column. Okay. And I say before that, I remind that desalter is adds to extract salt and base cinnamon. Okay, this is, I said before, the crude oil is heated into the two stages. Train consists cold preheating and hot preheating. Okay, after preheat train, it will be entered into the furnace with temperature about 270, and then the function of the furnace will be heat the oil to the temperature required for distillation column, and crude oil will be operating at atmosphere pressure. Okay, the salter is to extract salt and base cinnamon, and crude preheat train is the most critical system, which is it very required energy consumption. So to prevent this situation will be used the anti-fouling additive. Okay, I think that's all from me, and I will conclude that in this lecture we have to know a little bit more about what is actually crude oil, the function of distillation, and then preheating. I more focus more on crude preheat train. Crude preheat train is located at the beginning of the crude distillation unit, and the function of furnace, the function of desalter, and the crude oil will be separated into the different fraction. Okay, and then the crude preheat train is highly complex process and most critical system. Okay, I hope you understand. You all understand what I want to explain about preheating. So I think that's all from me. Thank you for listening.
Once crude oil comes out of earth, it is in raw state and cannot be used directly in any way. It must be refined to make it into usable products. Depending on the type of crude oil, it is treated by different refining processes to turn it into many useful end products. Mainly these products are fuels, lubricating oils, waxes, chemicals, plastics and many other products used every day in modern society. The refining process takes place in 3 steps to change the crude oil into finished products. In this process, the first step is to separate the crude oil into its naturally occurring components. This is known as separation and is accomplished by applying heat through a process called distillation. To simplify the process, we consider one tower where distillation process is taking place. Crude oil is supplied to a furnace before the distillation tower, where crude oil is heated and vaporized and it becomes the crude oil mixture. The vapor and liquid mixture is then fed into the bottom section of the tower. The feed section is the hottest point in the distillation tower and can reach as high as 400 degrees C. Components that are still liquid at this elevated temperature become the tower's bottom product. Components that are in vapor form rise up the tower through a series of distillation stages. The temperature decreases as the vapors rise through the tower and the components condense. The yield from a distillation tower refers to the relative percentage of each of the separated components, known as product streams. Products from the distillation tower range from gases at the top to very heavy, viscous liquids at the bottom. In all cases, these product streams are still considered unfinished and require further processing to become useful products. Light products, light are further separated into propane, normal butane, and isobutene. This stream is often referred to as liquefied petroleum gas, LPG, and is sold as a cooking and heating fuel. Naphtha could be blended into motor gasoline, but is more likely sent to a catalytic reforming unit for octane improvement. Kerosene is generally treated and used as jet fuel. Heavier distillate streams are also treated and blended into finished diesel fuel or home heating oil, or are further processed in conversion units such as fluidized catalytic cracking and hydrocracking. The routing of these streams will vary as product demand changes to either maximize diesel production or gasoline production. Lowest end of columns: asphalt, power generation and marine fuel.